Today is the last lesson of the unit. We're going to learn how to turn binomial distributions to normal distributions. This is probably the most intense and maybe most difficult thing that we've done in this unit, so just be prepared for that. So if you remember binomial distributions, they're yes or no questions, this or that, okay? So there's certain things that we have to do to change a problem from binomial to normal. The first thing we have to look at is, maybe it will move on. There we go. Okay, so this chart should look familiar. Okay, this is about finding probability with binomials. We have to add and subtract 0.5 depending on what it's asking for. So please write down this chart. I'm going to tell you that right now. If you write this down, it will make your life easier as we go through the examples. All right. The other thing I want to note here is that for all cases, the mean is n times p. The standard deviation is n times p times q. This is binomial distribution. We did this before. Now, how to change a binomial distribution to change it to a normal distribution. So the very first thing, we have to follow these steps every single time. All right? So the very first thing we need to do is we need to check to see whether it can be used. This is a really important step, and a lot of people skip it. So what you have to do is, in order to check, it's really simple, okay, you just can't forget to do it, is that you will take the n value times the probability, so however many you have times the probability, and make sure that it's greater than or equal to 5. Then you must also take the n value times the probability of it not happening, and make sure it's also greater than or equal to 5. If it's not, you cannot use a normal distribution, and you're done with your problem. The second step is to find the mean and the standard deviation. Fairly simple, n times p, and then the square root of npq. Then you will write the problem using probability notation, okay? So the probability that x is greater than or equal to something, or greater than, or less than, okay? Step 4 is to rewrite the problem using the continuity correction factor. That chart we just looked at is the correction factor, so then we'll rewrite it. Step 5 is to find the z-values, just like we were doing in sections 1, 2, and 3, okay? Finding z-values. And then step 6 is to find the solution. So pretty basic. It is kind of time-consuming, though. So, example 1. A theater owner found that 5% of patrons did not show up for the performance if they purchased tickets for. If a theater has 100 seats, find the probability that 6 or more patrons will not show up for the sold-out performance. So step 1, check to make sure we can do it. 100 times 0.05 is 5. So it says it's greater than or equal to 5, so this is okay. And then 100 times 0.95 is 95. So it's definitely a go. Okay, we can use the normal approximation for this. Second step, the mean, which we've already found, n times p, is 5. And the standard deviation, which is the square root of npq, 100 times 0.05 times 0.95, and that is 2.18. Okay. Then step 3 is to write it in the probability form. What are we looking for? We want to know the probability that 6 or more patrons will not show up. Patrons. The probability x is greater than or equal to 6. Step 4 is we use the continuity factor. We look on the chart and we rewrite it. So now it's x is greater than 5.5. This is using the chart to determine what this number will be. Step 5. Okay. So now we're going to find the z-score. So we use 5.5, not 6, because we use the continuity factor. Okay. So 5.5 minus 5 divided by 2.18 gives us 0.229. All right, and now we have to look this up on a chart, and I had some problems with this, so we're going to, whoops, let's do this first. So we're going to picture, we want to make sure we have the picture so we can see what we're looking for. All right, we're looking for the tail, so we'll have to subtract from 0.5 once we get the area. So that was wrong. There we go. Okay, so if I look it up on the chart, it's 0.0871. So I will subtract that from 0.5 to get my probability of 0.4192. So there is a 41% chance that 6 or more people do not show up for the show. Practice. The magazine reported that 6% of American drivers read the newspaper while driving. If 300 drivers are selected at random, find the probability that exactly 25 say they read the newspaper while driving. So go ahead and pause the video, do the problem, and then we'll talk about the solution. Okay, so here's the solution. So first of all, step one is we take the probability, which is 0.06, the Q, which is 1 minus 0.06, 0.94, and N is 300. So we do NP 300 times 0.06 is 18, and Q 300 times 0.94 is 282. So it definitely checks out. We can do the problem. Then we find the mean, which is 18. We've already done that up here. Then we take the square root of 300 times 0.06 times 0.94, 4.11. Okay, again, I'm just doing the formula, the square root of NPQ. So the probability is the probability that x equals 25. Using my chart, or the continuity correction factor, okay, it's 25 minus 0.05 and 25 plus 0.05. So this is kind of an obnoxious one because we have to do it twice. So if you look down here, there it's an area in between those two, these two numbers. Okay, so this is so we'll have to find that. So here's step 5. Is we've actually got to find z-scores for both of them. So 25.5 minus 18 divided by 4.11, which is the standard deviation, 1.82, and then 24.5 minus 18 divided by 4.11, 1.58. I look at them up in this chart, 0.4656 and 0.4429, and then since they were on the same side of the equal sign, let's go back. Since they were on the same side of the equal sign, I have to subtract them from each other. And I end up with 0.0227. So the probability that exactly 25 people read the newspaper while driving is 2.27%. All right, example 2. Here's an example 2. I've lost my notes. Okay. According to a recent survey, 53% of households have personal computers. If a random sample of 175 households is selected, what is the probability that more than 75 but fewer than 110 have a personal computer? So let's look at this example. So first of all, we're going to draw a picture so we can see what we're looking at. So okay, so the mean, how I calculated the mean, and I should have shown this on here, I apologize for that. Okay, it says 53% of the households have personal computers. All right, if a random sample of 175 households is selected, so the NP, 0.53 times 175, gives me 92.75. So that is my mean. All right, so now we're going to continue. What are we looking for? We're looking for more than 75, but less than 110. So we're looking for this area in between 110 and 75. Okay, so the first step is to see, is it possible? And usually when the probabilities are this like large, like in between, I would say 30 and 60, it almost always is. So NP is 92.73 and Q is 82.25. So it definitely checks out. We can do the problem. Okay, the second step. Find the mean and the standard deviation. So we already know the mean. The mean is 92.73. The standard deviation is the square root of NPQ. I think I was having some trouble. Okay, so NPQ, which is 6.6. Step 3 is the probability that x is less than 10, 110, and the probability that x is greater than 75. So that's what we're looking for. So in our chart, we have to do the continuity correction. So we have to do the probability that x is greater than 75.5 and that x is less than 109.5. So we have to find both z-scores using our formulas. So we're going to have 75.5 minus 92.73 divided by 6.6. That's going to equal negative 2.61. And then we're going to go 109.5 minus 92.73 divided by 6.6. That's going to get us 2. 2.08. So we look up both of those in the charts, okay, these two scores, and because they're one on one side and one on the other, we're going to end up adding them together. So, so 0.4955 and 0.4812, we add them together and it's 97.67. So the probability that 75, more than 75 but less than 110 households have a personal computer is 97.67%. All right, practice problem 2. In a member of a bowling league, 10% are widowed. If 200 bowling league members are selected at random, find the probability that 10 or more will be widowed. So we're going to pause the video, do the problem, and then I will talk about the solution. Okay. So step 1, obviously we check. Okay. NP is 200 times 0.1 equals 20, and NQ, 200 times 0.9 is 180. So we can use it. So that's always the first step. Then we find the mean, which is always usually found in step 1, is 20, and standard deviation, 200 times 0.1 times 0.9 equals, and the square root of that is 4.24. Step 3, we're looking for the probability that x is greater than or equal to 10, okay? And so the approximation is we do 10 minus 0.5, so we're doing the probability that x is greater than 9.5. So then we look at our picture and we're looking for the probability that it's greater than 9.5. So it's a huge number. This should be a really large percentage, okay, 9.5 or above. So we do 9.5 to find the z-score, minus 20 over 4.24 equals negative 2.48. So we find the z-score for this. The z-score is negative 2.48. The probability in the chart, which is 0.4934. I have to add to it this 0.5, so I get 99.34. So it was a huge number. See you tomorrow.